our next talk, Rachel Klima will be speaking for Bethany Ehlmann on the Lunar Trailblazer mission. Go
Hello.
ahead, Rachel.
All right, can I hop in? Yeah. All right. I am Rachel Klima. I'm Deputy PI of Lunar Trailblazer. Clive, if you want to go ahead to the next slide, I will dive in. As Barb mentioned, Lunar Trailblazer is another one of these missions that is in development to be launching relatively soon to characterize and follow up on the discoveries of surficial ice and water on the lunar surface. So Lunar Trailblazer is a Smallsat mission, fits in the Espa Grande volume, 200 kilometers. We were selected through the Simplex call, and we have just, NASA has just confirmed that we are looking for a rideshare, or we should be on a rideshare in mid-2023. So this is moved up from our original baseline. We're delivering the payload and the entire flight system in towards the end of this year, beginning of next year. So we'll be ready to go whenever they're ready to integrate us into that rideshare. What we're doing is we're using two instruments. So one that's a basically a descendant of the Moon Mineralogy Mapper that flew on Chandrayaan-1, and a thermal instrument which builds on the data collected by Diviner, and that is contributed by Oxford in the UK. So if you want to go to the next slide, I'll talk a little bit more about the data sets that we're collecting. So we're looking at this surficial water, but we are going to have a longer wavelength range with our infrared spectrometer and higher spectral resolution. So this will enable us to better characterize the form of the water or hydroxyl that is present. We also have a higher spatial resolution. Now, what's really exciting about this mission is that the thermal measurements that we'll be taking at the exact same time as the near-infrared data will allow us to characterize both the temperature within, at a smaller scale even than the pixels that we're looking at with the near-infrared spectrometer, but also to understand better the composition, the temperature, and the roughness of the surface that we're looking at in the near-infrared. We're following up on both where is the water, what is the form, and we're using repeat imaging to follow up on the questions about mobility of water on the lunar surface. If you can go to the next slide, please, talk a little bit more about the science of it. So, you know, when we flew the Moon Mineralogy Mapper, we didn't really expect to be finding water, so we weren't optimized to this. So to viewing it with the in the near infrared. With HVM cubed, we're going to have a more sensitive detector and the longer wavelength range to really get at the spectral nature of what we're seeing at this surface water in the top microns of the surface. Another aspect of Moon Mineralogy Mapper is that with covering this longer range, if you go to the next slide, we'll be able to look at the purity of the ice. So, you know, if we are seeing water at the surface, we'll also be able to observe whether there's organics or other materials trapped in some of these permanently shadowed regions as we image them over time with the HVM cubed instrument. So I'm going to catch you up on 30 seconds of time, I think, since we're a little bit behind, and go ahead and let you.
Thank you very much, Rachel. Fantastic